So what I'm going to talk about today is ways of reducing clutter in your graph visualizations. So oftentimes, graph visualizations become overloaded with clutter. Nodes and links obscure the screen and prevent you from getting any insight or any value from visualizing the data. So what we're going to talk about are different ways and techniques that you can use in graph visualizations to reduce the clutter, provide ways of getting insight and understanding patterns in graph data, even when there are large numbers of nodes and links in your data set. But first, before I do that, I'm going to start off with just a brief introduction about graph visualization and why you want to employ these concepts at all in general. The first idea is that graph visualization or graph data is inherently visual. So if I am trying to describe relationships and interconnected relationships between data elements, it's almost impossible to do so without holding up their hands and making imaginary nodes in the air and drawing lines between them. It's the structure of the data and the model of the data lends itself very well to being represented in this format. And as a result, you often will try to convey that in terms of a graph visualization with nodes and links drawn on paper or on the screen to somebody who then has to make decisions based on it, whether that's in a business context, an intelligence context, or in a journalism context. As a result, I'm showing over here on the right a visualization from the New York Times several years ago about a corruption scandal and campaign contributions among members of the United States Congress. I think that this is a really brilliant diagram that was put in the paper, manually created by their data journalist, where this person outlines the nodes and the links directly, put a lot of information on the links to show those relationships and the details of those relationships. And as a result, you get a very interesting picture of how all of these members of Congress are connected to one another in this scandal. Now, that was a very manual process. This was not created with an automated tool. And also, because this person was writing for a newspaper, they had to create all of this data on the page directly and couldn't use any of the techniques that we're talking about because it was actually written on a page and wasn't available on the screen. So some of the things that we're going to talk about today are what happens when you have an application. The user can actually interact with the data as opposed to having to see it all at once. The diagram over here on the right is only about 20 nodes, and it's already starting to get cluttered. It takes up most of a single newspaper page. So what happens? What can you do when you have thousands or even tens of thousands of nodes and you want to understand the connections embedded in those? This is a visualization of about 2,000 nodes and 2,000 links. And it's terrible. It's a complete mess. I work with a lot of customers who are working with graph databases for the first time, and they are their first instinct is to try to go off and get all of the data from their data source and bring it into a visualization all at once, and then just throw it on the screen and see what happens. And inevitably, this is what happens. You get something that is totally obscured the entire screen with nodes and links, no discernible pattern, no layouts help with this volume of data and this amount of clutter. So the question is, how do you start from something like this and end up with something like this, where it's very clear the insight that you're getting from the data? So there are several different types of clutter, and the ways of dealing with them vary depending on what it is that we're looking at. So we're going to start with the one on the upper right there. That is not that large of a data set. There's only a few dozen nodes on there, but every node is connected to every other node on the chart. And as a result, there are way too many links to really understand what's going on. So it's a very densely connected graph. And because of that dense connections, the links obscure the nodes and make it really hard to uncover what's going on. Below that, we're looking at a less densely connected graph with a lot of nodes, but even that's not too overwhelming in terms of the amount of data. But because there is one centrally connected node to almost everything else on the chart, you get this starburst pattern, which makes it a bit more difficult to understand outside of the starburst what other connections may be embedded in the data, and that's probably what you care about more than just understanding that one thing is linked to everything else on the chart. And then the larger one on the left here is a data set where we're trying to put too much onto the nodes, too many properties, too much data associated with each of the individual data elements themselves. It gives the user a lot of information about the node, but because we're cramming too much on the screen, you just eventually run out of pixels, and as a result, you can't really see what's going on in the chart. So we're going to talk about ways that you can deal with each one of these types of clutter in turn. So on this slide, I'm going to switch back and forth a little bit between talking about the concept and then showing you a demo where we've employed the concept. So the first one is interactivity, and I can't stress this one enough. You're, in many cases, not creating visualizations for the newspaper, but you are doing so inside of an application, especially inside of a web application. And that means that you have a lot more tools in your arsenal to be able to allow the user to see only what it is that they're interested in seeing and don't have to present everything all at once. So what the interactivity is allows you to create an interface where the user can ask for specific bits of data and then expand out from there. I'll show you a quick example of this here. So this is an example where instead of presenting all of the data at once, this is an IMDb type data set with movies and actors and actresses in movies. We start off with a base query saying, show me Lord of the Rings and the people who were in that, and bring those onto the chart. You can imagine if I had tried to visualize everybody in the entire IMDb data set all at once, it would be useless. It would be way too cluttered to make sense of. Chances are the user doesn't want to or need to see all of that at once anyway. Now, what I can do here is, as an end user, explore my way through the chart. Here's Hugo Weaving. I'm now interested in what he maybe what the movies he's been in. I may want to see who else has been in Lord of the Rings. I may want to expand on different movies and lay those things out. So what I can do is create that exploratory type interface to the data. The other piece that's really helpful here is the ability to filter. So instead of showing all of the data at once, or at least as the next step to showing all of the data at once, allow the user to filter down to the bits of data that are the most important to them. So let me show you an example of that as well. Here in this example, we're looking at public data breaches from 2013. So these are companies who have had breaches of their private data and have been stolen, and they've released that information. And what we've done is we've formed this as a graph by looking at who was responsible for that breach and the vector that they used to obtain that data. Now, it's a bit complex. It's a bit busy because we have a lot of those data breaches that we're trying to show all at once. The nodes themselves are both the attackers and the organizations that had their data stolen, as you can see the smaller nodes here. And we've done a couple of different things to make this a bit more understandable. So we've styled the nodes, both created larger size for the ones that are most well connected so that they stand out even when you're zoomed out, but also used what we call a donut around those nodes so that we can see what they're comprised of. And those colors that we're using on the donut show us the vectors of the attack. So for example, activist groups are mostly using advanced technologies, whereas regular employees of the organization are more often using either basic technologies or physical access to the systems or servers where they stole the data, which is something that you would expect. Now, perhaps I want to filter down and show only those attacks that use that advanced technology. So filters are a way that I can take a very complex chart, but only show me the data that's relevant to what I'm trying to understand. So here what I've done is filtered down to show me only those vectors. And then the time bar down here at the bottom allows me to even further filter by looking at specific windows of time. Say, for example, the month of September 2013, and here are those public data breaches that took place during that month. So this allows me, the filtering allows me to really zoom down and inspect the bits of the graph that are of interest to me, but then step back and see the context of everything else on the chart when it is important to understand those patterns, those overall broad patterns in the data set. Here's some further examples of filtering. So in this example, we've filtered out, or we're looking at malware and how malware propagates across a network. And we're zooming into a specific window of time and relaying out the data after we've done so to show, to be able to better understand the patterns of the malware propagation across just the window of time that I've selected. The other piece that's of interest here is what we're calling detail on demand. So in the examples of the clutter that I showed you a few slides ago, one of the examples tried to present too much detail about the nodes and the relationships in the chart when it was when we were looking at all of the data. But what we're doing in this screen capture here is showing you an example where you may want to understand the structure of the data overall, but not necessarily need to see the detail about every node until you actually ask for it. So what we've done here is we've created an interface where hovering over a specific node gives us more detail. So I can see that structure, find out who the most well-connected items are in the network, and then inspect those well-connected items to uncover more information about them, versus trying to present all of this to the end user all at the same time, which can get very cluttered. And then the last thing that I'm going to talk about today is called combining. So what we do in this instance is create groups of nodes and show how those groups are connected to one another instead of trying to put every node on the chart all at once. So I'm going to show you an example of this. So in this example, we're looking at members of Al-Qaeda and how those members are connected to one another via the intercepted communications between them. And we did a few things with styling to show those connections, to show the countries that those people are from. So for example, we're looking at a few people from Germany here. We see a few Saudi Arabian flags. Here's an American, and so on. But the network is too complex. It's a bit too busy to understand any sort of broad patterns in the data or to get any intelligence out of this network by looking at the big picture all at once. And it's not even that complex. There's about 220 nodes on this chart. We can see some patterns. So for example, we've got NCEP here, who's Malaysian. He's got a connection to this subgroup who's connected mostly to each other, but it seems like they communicate through NCEP to the rest of the network, and that stands out a little bit. In contrast, we've got some different groups of French flags scattered around on the chart that tell us that perhaps there are individual cells operating within France that aren't communicating with one another. But we don't really have a good sense of what's going on in this network, where these people are from and who's communicating with one another when the chart is this busy. So we have had in our tool, Keylines, a concept called combining, which allows you to group together nodes based on any common property and show how those groups are connected to one another. So I'm going to do that now, and we're going to combine by country. That gives us nodes which now represent the entire country in the network. And the size of the node corresponds to the number of individuals inside of that country. The width of the link is also showing us the number of communications between those people in those countries and the people in other countries. So you're getting a broader or zoomed out view of the network and a much less cluttered chart by looking at this. Now I can uncombine any one area to look at the details. But one of the new things in Keylines 4.0, which is set for release in the next couple of months, is that it's a sort of middle ground between looking at the detail of the chart, all of the nodes broken out into the individual data elements, and the combined or grouped view that we're looking at right here. So as an example here, let's say I'm interested in Morocco. I'm interested in finding out what the individuals inside of Morocco are doing. So this is called open combinations. What we've done is we've expanded out Morocco as a group, showing us the detail of the individuals inside of the country of Morocco, how they're all connected to one another, and how they're connected to the other countries on the globe. So for example, if I hover over or select this individual from Morocco, I can see that he's connected to other Moroccans, but also to somebody from Afghanistan. This person here has a bunch of other connections internal to the country, Afghanistan, and from somebody whose country we don't know. So it gives us that critical information grouping together nodes, but allowing us to see inside of that group to the detail of the data elements that are inside. Now, this is helpful because it presents a decluttered chart, but shows us the detail that we need to see when it's relevant to us. Now, we can also group together the country nodes to create sort of super combinations. So let's do that. And now what we're looking at is nodes which represent the entire region. And those nodes comprise the countries inside of it. So if I open up the Southeast, we've got various countries from Asia and Australia. I can then zoom in on those individuals and see on those individual countries and see the data that's inside of those. So I've expanded now on Indonesia to look at the individual Indonesians in my data set. So this can go as many levels deep as relevant, and it really is a great way of showing the context or the broad overall view of the data, and then creating this interface to be able to zoom into the bits that are important at the time. Let's open everything up so that we can see how this looks when we're looking at all of the data self-contained in those combinations. So if I zoom in, we can see, for example, we've got that super node which represents the Southeast with the countries inside of it. We've got the Middle East with the countries here. We've got North America with the United States and Canada. This view has the same number of nodes as we were looking at previously, but because they are grouped together by the property that we've determined is relevant, then it creates a much easier to understand connection. Now, if you're looking at the data in a different format or a different domain, country may not be the best way to break these out. You may want to use some other property of the data to group them together, but the concepts would be similar. And then I've got a few things with combinations to show you as well in the slides. So let's step back there. Here's a couple of examples where combinations, open combos, can be really useful as well in different domains. So here we're looking at communications patterns within an organization. So we've got people who fall under different teams within a company and who they're emailing. And we've grouped them together by those teams. So we can see who falls under which team hierarchy, who they're communicating with, without having them all broken out into the individual data elements where you can't tell who somebody reports to. It's a very powerful way of uncovering what may be going on with this organizational structure. Another good example of where open combinations can be valuable is in the IT domain, if you're looking at infrastructure or cybersecurity. So what we're showing you here, for example, is different zones of a network and the individual network elements that are inside of those zones, but grouped according to the zone that they're in, so that we can immediately uncover only the communication or the IP flow across zones and not worry as much about the detail of the IP communications within a zone. One other thing that I was going to talk about before the end was layouts as well. So layouts are not always the most helpful. So if I were to, I'm going to step back here just to show you this piece. If I were to run a layout here, and it wouldn't really help. There's just way too much data. The densely connected graphs don't lend themselves to layouts that well, because the links just obscure any sort of insight that you're trying to get. And so, for example, this densely connected chart up here on the upper right, where everything's connected to each other, there's no place that you can put those nodes that makes that any easier to understand. But there is certain layouts that can be valuable in certain circumstances here. So in this case, for example, if you have a tree type structure to your data, then it can be really helpful to organize it as a hierarchy and show sort of the that sort of flow down if it's a network, or that organizational structure or hierarchical structure if you're looking at an organization. And that's just convenient ways of placing the nodes which help highlight specific patterns that you may want to find in the data. So what we're doing in this example is we're cycling between two different organizations or layouts of the data, which can be valuable depending on the patterns that you're trying to uncover. So the hierarchical data is useful if you have that tree type structure, or if that's relevant to what you're trying to uncover. Whereas the second layout is showing us more of a radial view, which is I want to focus on that rectangular structure node in the center and see how everything else is connected to it. So within keylines, we have a number of different layouts which are useful in different circumstances. Let me step back and show you one example of that as well. So if I come back here to this example, the standard layout is one that we use to show me, try to minimize the number of links that cross over one another. It makes for a very readable chart. However, it does not imply any sort of specific organizational structure to what we're looking at. However, the hierarchy layout, as we showed you in the screenshot, will create that specific fall down from the lead node that I've selected, and I can change which one falls into the peak of the hierarchy and change the way it's drawn. And then the radial one that I showed you is helpful if I want to see how all of the items are relevant or connected to this certain item that I have selected. Those things can be really helpful if you have a loosely connected network, but are less helpful when you have a densely connected network, because it doesn't really matter where you put the items that you have selected. Okay, I've got some time left at the end here, so what I'm going to do is pass it back to Sam, who's going to take some questions, and I'll be happy to answer those as we go forward.
Great, thanks for that, Corey. Very interesting. We do have a few questions. I'll start with ones that have been sent through before today, and I think you've pretty much answered the first one, but I'll send it anyway in case you have anything else to fill in. But Malik asks, says that he's using visualization to model his entire organization's data, and it's looking too cluttered visually with numerous nodes. Is there any advice?
Right, so that's actually the point of the webinar that we just did, was to provide techniques on how to do that. I think if I were to just give one thing to stress is that no matter how much you have in your database, it doesn't always help. In fact, it's often a hindrance to try to show that to the end user all at once. So start from whatever the use case that you're trying to accomplish is, bring those nodes into a visualization, and then create that interactive environment where the user can explore their way or issue new queries or select certain items on the chart and see what they're connected to, as opposed to throwing it all on the screen at the same time. But the other techniques that we talked about here, the filtering and the grouping, can come in handy as well.
Great. Okay. G's got a very good question. G's interested in grouping large number of links rather than nodes. Is that possible?
It is. However, when it's most helpful is when you have large numbers of links between the same two nodes. So, for example, if I'm modeling a transactional database where I'm looking at, say, money transfers or something like that, where you may have many different connections between the same two nodes, sometimes it can be really helpful, instead of drawing each one, to summarize them, to say, instead of having $10 sent one way and $15 sent the other way, maybe the net transfer is what you care about, and represent that just as a single link showing that one-way connection. Or, for example, in the email example that I showed you during the webinar, where we're looking at individual emails between members of teams within an organization, each email doesn't have to be drawn as its own link. It can be summarized and use the width of the link to show us the number of communications between those people. So that can be a very powerful way of cutting down on the clutter.
Okay. Chris asks, how much of the decluttering process should take place on the back end rather than the front end?
Yeah, so that's a very interesting question, and the answer varies a bit based on what you're trying to do, but it's, in many cases, it's both. So you want to reduce the amount that you send to your visualization. So when you're starting from your database, only send the results of a query or a highly filtered version of your data source to the end user. Especially if you have terabytes and terabytes of data, you wouldn't expect the end user to hold that in their browser anyway. But then even once the data is in the browser, allow the user to further filter it down to only the bits that are relevant to them. So I think of it as kind of a two-stage process where you do filtering on the server side to get it down to a manageable volume, and then the user does the filtering on their side once they understand their use case and what it is that they're trying to uncover.
Okay. And over to, we've actually received quite a few questions in the last few minutes and during the presentation as well, so I'll go through those now. Andrew asks, how do you define the base query in order to start the data visualization process in Keylines?
Yeah, so that is, oftentimes it's a search form. So many of the data sources that our customers work with have a full text index. So you could build a single box search interface into your data source and then take the results of that and then present that to the end user in graph form. Or perhaps you need a more structured query interface where the users ask more detailed questions of the data and get those results back. So in almost all cases, that initial search of the data that you bring into the visualization, the user interface for that is actually outside of the visualization, the initial query that you offer. And then they can interact with the rest of the data by doing those expands from within the visualization itself.
Okay. And then we have a question from Ter, who asks about accessibility and how do you handle accessibility issues for diagrams like these, specifically, or for example, people who are blind or colorblind?
Yeah, it's a very good question, and I don't have great answers for that. Data visualization, in the name itself, has visual, so it's hard to come up with a way of presenting the data that would be accessible to somebody who is blind, for example. And I don't have any good examples of alternative ways of presenting that data. So a screen reader, for example, would not give you that same intuitive insight into the data that you might get from other ways of interacting with it. So to be honest, for people who are visually impaired, it might be better to step back to a tabular view of the data and have a screen reader, for example, show you the data in that format. Or you could have, say, some automated algorithms which pick out the most interesting or relevant nodes and then read the information about that to somebody. But the color blindness is a very important point as well, in that color is a very important thing to take advantage of when you're creating visualizations, but you always do have to keep in mind that your audience may not have the same perception of color as you do. So make sure that you're using colors that will stand out and contrast one another, even to somebody who's, for example, red-green colorblind.
Okay, and Debbie asks if combinations can be linked to graphic coordinates and used with GIS maps.
So we do have a capability within our tool of overlaying nodes on top of a map. I didn't show that in this webinar, but if the nodes themselves have coordinates and positions in space, then it can often be very helpful to show them superimposed on a map. However, in some cases, especially if you have a lot of data, that can create more clutter than the value that it provides. So for example, you may have all of your nodes clustered in one small area of a city, and you may not be able to see those interconnections. You lose the ability to run layouts when you have your items superimposed over a map, because they have to align with where the geographic coordinates are. And so that makes it a bit more difficult. In our tool, we've created the ability to switch back and forth between a graphical view and a map-based view of the data. Now, when it comes to combinations on maps, yes, that it can be really helpful. So oftentimes, as you zoom in on a specific area of the map, you want to see that data broken out into more detail than when you're zoomed out at, say, a countrywide or a global view. And we do have that capability within Keylines as well.
Okay. Then Andrew again asks if this technology could be integrated into a CRM system such as Salesforce. The use case would be to map personal relationships.
Yes, in fact, it can be, and we have had customers who have done exactly that, created Salesforce plugins that include Keylines as a component of it for various domains. So that is something that's entirely possible.
And Bassam asks, do you support mobile, specifically Swift or React Native?
We do support running in a mobile environment. We have a touch interface within Keylines so that end users can interact with the data with their fingertips. And there's also a multi-touch interface so they can pinch to zoom in on the chart and things like that. And then as far as the mobile JavaScript frameworks, we do support those as well, so that you can create your mobile application as long as it supports third-party JavaScript. Keylines would work just fine.
And finally, we have a question from James. Generally speaking, should layouts such as hierarchy and radial be used with selected nodes in mind, or is there a use to those layouts without selected nodes?
Yeah, so that's a very good question as well, in that what I showed you today, the user selects the node that they want to be either the center of the radius or the apex of the hierarchy. However, in many cases, the graph algorithms can discern or infer what that central node should be. If you have a directed graph, which just means that the links themselves have arrowheads and a directionality associated with it, then it's possible to step back on those arrowheads to find the root node and make that the apex of the hierarchy, for example. So depends on the use case, but in many cases you can algorithmically determine what should be the center point of the node. Keyline supports both.
Great. Well, thanks very much, Corey, and thank you everyone for joining us today. If you have any further questions or you'd like to see any more demonstrations or have any further discussions, please feel free to contact us. Corey's email is there at the bottom of the screen. My email is up in the presentation, which you'll be getting later today, so the whole webinar will be sent to you as well by email. Thanks again for joining, and hope to speak to you soon.